Section 2.6 will be about solving linear and absolute value inequalities. Linear and absolute value inequalities. So let's start with the linear inequalities. The linear inequalities. A linear inequality is a mathematical statement containing at least one of the following symbols. This is the less than, that's greater than, over here we have the sign less than, and then when you have the bar, you have greater than or equal, and then less than or equal when you have the bar with the less than or equal less than sign. When the bar is underneath, you have less than or equal. Now we must understand that when solving an inequality, a linear inequality, we are subject to have an equation that can be presented in one of those three formats. The solution of this equation can be presented in one of those three formats. Can either be the set builder notation, graphically on the number line, or in interval notation, or all three of them. Let's go over each one of them in each scenario as the outcome of a linear inequality. So when you're solving an inequality, what is it is your answer is going to come out either x greater than a being a number, a real number, x less than a, x greater than or equal to a, x less than or equal to a, or you can have an inequality, a compound inequality, where x is in between the two of the four inequalities that we presented in the first paragraph. But now we have to understand, we always have to remember the value is included in the set of solution when you have the bar underneath of the inequality sign, and the value is not included when you don't have the bar underneath of the inequality sign. So that explains that we can have an inequality as not this one exactly, can be a less than or equal x less than b, can also have a less than or equal to x less than or equal to b, also can be a less than or of less than x and less than b. So can be either one of the four, but we can present one of them and then you would get the sense of how it would work for the three others. Given with the bar, you put you know what to do, and when it doesn't have the bar, you will know what to do. Now let's start with the set builder notation. Now for the set builder notation, you are describing the set of solution. It will be the set of all x values such that x is greater than a. Obviously, you see that I copied the same inequality that I had from the solution. I just define the set of solution by writing in with using the braces. X is all the name of all the elements inside of the solutions, but X should verify the inequality that you have at the end of the process, algebra process, of finding isolating X. So that's still going to be the same for all the inequalities. So that's why I'm going to copy this first part of the inequality of the set builder for each of them. So that's going to be the same here. X such that, X such that, and X such that. Then I'm going to write the same inequality. That's X less than A, X greater than or equal to A, depends on how the solution is presented. X greater than, less than or equal to A, and X A less than X less than or equal to B. So that is the set builder notation of your solution. Now on the graph, you're going to want to have the number line. Say that's my number line here. And that's, say that is A. This is A. The solution proposes that X is greater than A. Without the bar, you're going to exclude the value A by putting an open circle. Gonna put an open circle to exclude the value A, because when the bar is not there, A is excluded from the set, and then it's A greater than, that means we will take anything that is greater than A as the solution. Anything greater than A will be seen as a solution. Anything greater than A. Now, let's see if A is less than. So A less than, X less than A. Let me put A here and say that's A. It's not included because you don't have the bar. And less than A means on the left side of A. On the left side of A. Left side of A. Now, if A is greater, if X is greater or equal to A, you're gonna have the same scenario. The only difference is that the same scenario as when A is, the same scenario as when A is greater than, X is greater than A, with the exception that A is included. For that, we put a closed circle. And same thing as if A is included, meaning that X is less than or equal to A being a real number. So A is included, that means you're gonna have a closed circle. With the bar, you keep a closed circle. Without the bar, the inequality bar, you open the circle, meaning A is not included. In the last example, that's the number line here, given that b is bigger than x, let me put b right here and then put a right here. There is an open circle on a. It's an open circle because there's not we don't see the bar. And then on b, there is a bar, meaning that b is included. B is included in the solution set. So the solution will be everything in between A and B. Everything in between A and B, and B is included with a closed circle. Now with the interval notation, we should remember, if you're going to the right, that means the numbers, the bigger the numbers get, you still can have them as part of the solution. And the bigger number imaginable would be positive infinity. So that means the solution will start at x equals start at a, not including a. For not including, you're gonna put a parenthesis, and for including, you're gonna put a bracket. So it's going to be negative a, it's a to infinity. And then over here, since you're going to negative infinity, you always start from left to right, not the number line. That's not your number line. It's going to be negative infinity on the left and positive infinity on the right. If you are going to the left, you're heading to negative infinity. So reading the number line, it's going to be from negative infinity to that number here. So that's from negative infinity to a with the parentheses, because a is not included. And then when the circle is closed, the parentheses of the less than or equal scenario would be replaced by a bracket. That's the only difference. And then the less than or equal, we will do the same thing, replacing the parentheses on A by replacing the parentheses on A by a bracket, since A will be now included. In this last compound inequality example, that was an open circle, so we put a parenthesis on A, and then that's a closed circle, B would take a bracket. Now with that, let's start some examples. And in these examples, we're going to present the solutions in both in all the examples, set builder notation, graph, and interval notation. Let's start with this example. We're gonna solve the inequality negative 8x minus 32 is greater than or equal to 48. Now to isolate x, we're gonna start adding 32 on both sides. That is negative 8x greater than or equal to 80. Divide both sides of this inequality by 8, negative 8. So we should remember that when both sides of an inequality is divided or multiplied by a negative number, we must flip the direction or reverse the orientation of the inequality sign. So with that, instead of having, after dividing by -8, instead of having x greater than or equal to, we're going to have x less than or equal to -10. The fact that we divided by -8, it reverses the orientation of the inequality sign. Now, -10 now becomes the A value that we had on this table. We can tell that the situation we're seeing here corresponds to this case. So that means that we have the set builder notation. The set builder notation is the set of all x such that x is less than or equal to -10. And then B, let me use the number line here to sketch the solution of the inequality. Looking for -10, that's -10. And then it's less than or equal, so I'm going to have a closed circle on -10, because -10 is now included. And then the left side of -10, since x should be less than -10, so we would take everything on the left side of -10 as the solution. So the interval notation of the solution is -infinity, because when you go to the left, it goes to -infinity. It gets smaller and smaller all the way to -infinity. And then -10, this time -10 is included, we put a bracket. Now let's move on to the next example. So we solved, isolate the x, solution in set builder, graph it on the number line, and interval notation. And we're gonna do that for all the solutions, all the examples. Next example, number 2, we have -1, if you will. That's your -1 here that you're going to distribute over, times 8 minus 2x less than 32 plus 10x. So let's distribute that -1 here to remove the parentheses. That's -8 plus 2x less than 32 plus 10x. Let me subtract 2x on both sides. I'm subtracting 2x on both sides. That cancels the 2x on this side. I'm left with -8 less than 32 plus 8x. And then if we subtract 32 on both sides, that would give you -40 less than 8x. And then if we divide both sides of this equation by 8, by dividing by 8 on both sides, we'll get -5 is less than x. So we have -5 less than x as the inequality, final inequality. So this is this. And if you want, you can say that this is also x is greater than -5, right? If -5 is smaller than x, it would mean that x is greater than -5. So we have this. We can present the solution set in all different formats that we talked about. First, we can see the set builder notation. The set builder notation. So that is the set of all x values such that x is greater than -5, right? And let's sketch the solution on the number line. -5 is right here. We're going to keep it with an open circle since -5 is not included. And then x is greater than -5 means that everything on the right side of -5 will be considered as solution. So, and then we can say that's the B graph. And then the interval notation in C, interval notation, is the set of that is -5 with the parentheses because -5 is not included to positive infinity. Next example. In our next example, we should distribute first to cancel the parentheses. Let me distribute -7 over, and I will distribute +3 here as well. So that is 8 minus 14a minus 21 less than or equal to 3a minus 30. Let me add 14a on both sides. So that is 8. Okay, so let's combine 8 and -21. So that will be -13. -13 less than or equal to 17a minus 30. And if we add 30 on both sides, we will get 17 less than or equal to 17a dividing by 17, we get 1 less than or equal to a, or a is greater than or equal to 1. Set builder notation. Set builder notation is the set of x such that actually set of a this time. The variable is a, set of a such that a is greater than or equal to 1. And on the number line, what we have is we're looking for 1 with a closed circle. We need 1 with a closed circle on 1. And then solution will live on the right side since A is greater. So on the right side of 1 will be everything on the right side will be solution of this inequality. So, and then that's B, the graph. And then C, the solution in interval notation. Interval notation is from 1 with a bracket to infinity or with parentheses. Example number 4, we would need to distribute the 3 outside and the 4 on the other side here to get 24x minus 27 plus 17 greater than 24x plus 4. Now, we can combine like terms. 24x minus 10 is greater than 24x plus 4. By subtracting 24x on both sides, you cancel the 24x. We are left with negative 10 is greater than 4. Well, what we need to realize in this situation, we cancel the variable on both sides of the inequality, which means we're going to have to make a conclusion based on the statement that we have on whether it's a true statement, which will mean that all real numbers are solution because it does not depend on the variable, or if it's a false statement, then there will be no solution. This statement, negative 10 is greater than 4, is a false statement. Because it's false means that there is no solution. So a solution will not exist. There's no solution. Let's move on to the next example. Well, please note that it's a false statement. Let's see an example. Say I had negative 10 is less than or equal to 4. Well, this statement is a true statement because negative 4 less than or equal, it's one or the other, one or both. If one of them is verified, then it's true. Well, 4 is greater than negative 10. So then that would have made the solution all real numbers. So you need to test the statement on whether it's true or false to decide whether the solution is all real numbers or no solution. In this case, it was no solution. Let's look at the next example. So let's try to eliminate the parentheses first. We can distribute the negative 1 over. So that would be 10x minus 4 less than or equal to 6x minus 3 plus 5x. Let me see if it's 5, because 5x. And now let's combine like terms. That's 11x right here. 11x minus 4 less than or equal to 6x minus 3 plus 5x. We can combine like terms. That's 11x minus 4 less than or equal to 11x minus 3. Now, by subtracting 11x on both sides, that takes us to negative 4, because that cancels the 11x on both sides. Negative 4 is less than or equal to negative 3. This statement is a true statement, because when you have less than or equal, if it's less than, it's true. If it's equal, it's true. Or if it's uh, uh, um, both of them, then it's also true. So that is true, meaning that all real numbers is solution. So in in set builder notation, you can write all real number solution as set of x such that x is a real number. And then on the number line, it would be the entire number line, because all real numbers or solution will be the entire number line. And then in interval notation, in interval notation, it would be the set of negative infinity to positive infinity. So that's all the scenarios possible when solving an inequality, a linear inequality.